In this video, I will be talking about the section 6.5 Day 2 notes. In today's section, we are going to talk about adding and subtracting radical expressions. And so in the previous video, we did a little bit with multiplication and division. We'll come back to that at the very bottom with 7 and 8. But with addition and subtraction, it follows the same rules as combining like terms with algebraic expressions. Let me give you an example. So for number 1, let's pretend that this was 9x plus 3x. We all know that 9x plus 3x is 12x, and you'll notice that the x itself doesn't actually change, it's the coefficient in front that we're looking at. So if I take 9 root 2 plus 3 root 2, that would mean I would have 12, so 9 and 3, and then since root 2 is the same, I can combine them, but the root 2 stays the same, just like the variable here stays the same. So you can add or subtract radical expressions if they have the same root, and the number underneath the root is the same. They have to be like terms. So for number 2, I have negative 16 cube root 4 minus 1 cube root 4. So the roots are the same. Negative 16 minus 1 would be negative 17, and then cube root 4. So to add or subtract radicals, they have to be like terms. So then when we go over to problem number 2, you'll notice that while the 2 is the same underneath the roots themselves do not have the same index. As a result, we cannot combine these. And probably the best example I can give you is if I said 5x to the third plus x. These both involve the variable x, but since they have different powers, I can't combine them. So not only do the numbers have to be the same, but the index itself has to match up as well. And so if we go down to problem number 4, I have 5 square root 8 plus 3 square root 2. So they are both square roots, but the 8 and the 2 are not the same. So I can't combine them yet. And the reason why I say yet is because we can actually break down 8 underneath the square root. So we know that 8 is 4 times 2. The square root of 4 is 2. That 2 comes out and multiplies with the 5 to give you 10 root 2. And then I've got that plus 3 root 2 on the end. 10 root 2 plus 3 root 2 would be 13 root 2. And that's your answer. So in general, what you're going to see is you'll want to break down the numbers underneath the root to see if any of them can be added or subtracted together. So we know that in number 5, 12 underneath the square root is 4 times 3. 48 is 16 times 3. And 18 is 9 times 2. So 4, the square root of 4 is 2. 2 comes out and multiplies with the 3 to give you 6. Root 3 plus 4 root 3 minus, and then the square root of 9 is 3. 3 comes out to give you 6, and then root 2. Putting those together, I will get 10 root 3 minus 6 root 2. And one more of these before we go down to some multiplication and division. For number 6, you'll notice that this one has to be broken down before I can combine anything. 54 underneath the cube root would be 27 times 2. And then I have that x to the 4th there. So I'm going to rewrite that first one, 2x cube root 2x minus. So the cube root of 27 is 3. The cube root of x to the 4th, so 3 goes into 4 once with 1 left over. So I end up getting the exact same amount underneath the root. So 2x minus 3x is negative x, and then the cube root of 2x stays the same. So adding and subtracting, I think, is a little bit easier than multiplying and dividing. And the reason why I say that is because dividing has a lot of steps to it. So let's look at two more problems when it comes to multiplication and division. Number 7, you'll notice they're asking us to square this binomial. We know that to square a binomial, it looks like this. I'm going to multiply or double distribute here. Square root of 3 times the square root of 3. If you already know that that answer is 3, you can list that. But I'm going to show my work here, so I'll make it the square root of 9. Minus root 3 times root 4 is root 12. There's another minus root 12. And then negative times a negative is a positive square root of 16. And if you already know that's 4, that's fine. So I'll go ahead and take the root everywhere. Now 12 is 4 times 3, so that's 2 root 3. So then my answer should be 7 minus 4 root 3. So these are like terms, and we just learned that we can combine those up here in the notes, and then 3 and the 4 make 7. So we're going to end here with one more problem, and you'll notice that this last problem is division, and there are some roots in the denominator that we need to take care of. From the last section, we talked about how if you had, let's say 2 over root 3, you would have to get rid of the root 3 by multiplying by that root 3 over root 3. But the key was that this is a monomial, okay, so there's one term in the denominator. Here I have a binomial. So when it's a binomial, you are still going to have to multiply by something, but the something is going to be a lot different. You're going to multiply by the conjugate of the denominator, and that would be 4 plus root 3. And I'll show you why that works and why we need to use it here in a moment, but go ahead and write that down with parentheses. All right, and I'm going to go ahead and use some FOIL here. 1 times 4 is 4. 1 times root 3 is root 3. And then I have root 2 times 4, so that's 4 root 2. And then root 2 times root 3 is root 6. None of those can combine, unfortunately. They're all different terms, and that's okay. Now the denominator. Watch what happens since I use the conjugate. So instead of using 4 minus root 3, I specifically wanted to change that sign. 4 times 4 is 16. 4 times root 3 is 4 root 3. Then I will have a negative 4 root 3. And then negative root 3 times root 3 is negative root 9, which you can just write as minus 3. But since I used the conjugate, these two things right here are opposites. And so the roots drop out from the denominator because not only are those going to cancel, but I know that the square root of 9 is 3. So notice there's no more root in the denominator. So 16 minus 3 is just a 13 left over. And then whatever you have up top, if you can combine any of that, great. If you can't, that's fine. But you'll notice that we do not have a square root left over in the denominator. Make sure you pay close attention to this and remember that you multiply using the conjugate.